Hello friends and welcome at my channel. Today I would like to explain something new about limits. So we write a limit n towards infinity of an is equal to a if and only if um, for every epsilon which is bigger than 0 you can find a natural number n. There is an n out of the natural numbers such that for every n bigger than capital N, the distance between an and a is less than the given epsilon. All right, so this is the definition for the limit. Why is that important and why should we use it? Well, the thing is, you see, if we have, let's say, n is natural number, let's say 1 divided by n. Okay, so we would write limit n towards infinity of 1 divided by n. Well, it is 0. How do we know it? Well, the numerator isn't changing, it's 1. The denominator is increasing. This is infinitely large. So we're dividing 1 by a huge number, which is approaching 0. That makes sense, right? But we still want to somehow use our definition. So, like, this is what we see, but what we see, it's not necessarily what is right. So let us see what is happening if we're having, well, an minus a less than epsilon, and let's say this epsilon is depending on n. All right, so how can we prove it? Well, let's see. A is equal to 0. This is our approach, and we would like to find a connection between n and epsilon. Better to say, we want to rewrite n as an expression depending on epsilon, because epsilon is given. So maybe I shouldn't write epsilon depending on n, but rather n is depending on epsilon. So this is less than epsilon. We don't care about the absolute value because 1 divided by n is anyway positive. So we have 1 divided by n is less than epsilon. And that means because epsilon is a distance which is bigger than 0 and 1 divided by n is bigger than 0 as well, we can solve it for n, and we know that n is just bigger than 1 divided by epsilon. What it means is the following. Imagine you're giving me epsilon, which is given to 0, which is set as 0.01. So for which numbers n am I never leaving the area around the limit with a radius of 0.01? Well, you see, n is just, well, let's say equal to 1 divided over 0.01, which is 1 divided by 1 divided by 100, which is a multiplication times 100. So this is the story. So for every n which is bigger or equal than 101, the distance from all the members of the sequence to our limit is always less than epsilon. All right, does it make sense? I hope so. Let us see maybe one more example. We are considering, let's say, an, where n is a natural number. Well, 3n plus 2 divided over n plus 1. Okay, so how can we compute this one? What is the limit? Well, you may see limit n towards infinity, 3n plus 2 divided over n plus 1. Well, in order to see it clearly, I mean, maybe if you're familiar with this, it's immediately clear it's 3. But if you're new to this topic, I suggest you multiply times 1, which you can rewrite the way you like it, and that would be 3 plus 2 divided by n divided over 1 plus 1 divided by n. Oh, and I am new to the topic as well. As you can see, I forgot the limit. This is one of the kind of beginner's mistake. I'm sorry about that. So this one is approaching 0. This one is approaching 0 as well. And you see we're getting to 3 divided by 1, which is 3. But can we like prove it with our definition? Yes, we could. Let's say we have a given epsilon which is bigger than 0, and we have a, well, pretty nice guess. A is equal to 3. So what we're trying to compute is 3n plus 2 divided over, yeah, was that correct? Yes, divided over n plus 1 minus 3. So this should be less than epsilon for some given n, and we are going to find the value of n. So let's bring it to the same denominator. That means we have 3n plus 2 minus 3n minus 1 divided over n plus 1 should be still less than epsilon. Those two are gone. 2 minus 1 is 1. So we're having 1 divided by n plus 1 less than epsilon. N plus 1 is a positive number. Epsilon is a positive number, so we don't care about the direction of the inequality. 1 divided by epsilon is less than n plus 1, so n should be bigger than 1 divided by epsilon minus 1. All right? Maybe you've heard about ceiling function or floor function. Those are so-called Gauss functions. So let's have a look. Let's define our n as 1 divided by epsilon plus 1. Well, minus 1 was. And we say for all n's bigger than 1 divided by epsilon minus 1 ceiling function. That means we are taking the biggest natural number around. Let me clarify this idea. So 6.1, for example, the ceiling is 7. 6.9, the ceiling is also 7. Okay, so the closest number which is bigger or equal to the given number. All right, so this is the idea. And if we define it this way, we always have the value of n, which we're looking for these purposes. Okay, so this is a kind of solving some examples, but also kind of introduction into limits. And we're gonna make more in the next couple of videos. Thanks for watching. See you guys.